Hello and welcome to this 5-minute short on heat loss per pipe in Flonet. So the starting point of this is actually Capri and this sheet heat loss from a pipe profile, and there's a 5-minute short on how we got to these results and how this is set up. This is going to be our starting point for this particular 5-minute short. So what this sheet, if I scroll down here, has shown me is I've got a 50-meter pipe, I've got a 10-mile-an-hour wind. I scroll down here, I can see my total heat loss from my pipe is 15.7 kilowatts. I can see my heat loss rate as well. So that's a nice, useful bit of information, but I want to put that into actual Flonet model because I might have several pipes going different places, different lengths, different nodes. So I could build this up in a bit more detail, potentially iterate a little bit around this, but we want to put these into Flonet. So how are we going to do this? We've got Flonet. And we need to make sure obviously the two modes are the same. And I'm keeping this really, really simple. I'm going to have an inlet node, an exit node, and a pipe just to start off with. Obviously your mode's going to be a lot more difficult, but this will give you the basic principles. So let's start off with a pipe. We double click on there. We've got 50 meters, 2-inch, bit of roughness. So same diameter length pipe we had in the Capri sheet. My inlet node, check my fluid. So this is water at pressure, so 100 degrees C. And with Flonet, you give it various points. I've just gone for 10 bar gauge, 100 degrees C, 990, 880. Doesn't have to be that organized, but this is just giving it some physical property data again, so the model can interpolate around those various parameters. And you could give it more points if you want to. 3 is the minimum if you want more. If more makes sense, then that's fine. But that's the way we've set this up. We did the model on the Capri sheet. We said it's a 10 bar gauge. So what I've said for this inlet node, I've got 10 bar gauge and I'm fixing that because that's what we had. So that's how that node is set up. And then my exit node, what we said was in the model in the Capri sheet, we had a flow rate of 10,000 kilograms an hour. So I've put that in the flow rate, I've fixed it, and I've told it that's an out. So that's the exit node, and I've fixed the flow rate. This is the inlet node, and I've fixed the pressure. So that's got enough parameters for Flonet to then go off and do some calculations. Now at the minute, it's not going to do anything exciting. It'll just tell me the flow rate through here. Actually, when there's a flow, it'll tell me the pressure down here based on that pressure and that flow rate. So what we want to do now is to mimic that heat loss. So we're going to drag a heat exchanger in here, and it's going to split the pipe. Now we need to be a little bit careful to see how it's split. Now I've got it set up on this one, so it splits at 50-50. So I've got 25 meters on this side and 25 meters on that side. Where that happens, if you go in options, behavior, you can see here how we want to split that. So as you drop a fitting in, how that line splits, but it defaults the same length. If it's the same length, it would basically double the pipe. And I wanted it half and half, so I had it split on half. I then need to put something in my heat exchanger so I could tell it a fixed temperature difference. It's going to change it by 3 degrees, whatever it might be. But I actually want a heat duty. So if I go back to my sheet, I've got 15.76, wonderfully precise value. And of course, I'm losing energy. So I want to take it out. So I'm going to put the minus sign in. So that's going to take energy out of the system. I can then press my calculate. So we've got lots of solvers and stuff. Let's go straight to results. And then what we've got here is we can see our temperature in our node 1, and it's coming out at the back end at 98.6 degrees C. So we've taken that energy out and we've got the right answer. So that's how you would mimic and monitor, if you like, or model heat loss due to ambient conditions through Flonet. And obviously you could build a much more complicated model using the two devices. Hopefully that's helpful. Thank you very much.